Hello everyone, in this video, we will introduce the functions related to spectral index calculation. First, let's briefly introduce the spectrum. In remote sensing, the spectrum is defined as the distribution of energy, through reflection, absorption, or emission of radiation, as a function of wavelength when electromagnetic radiation interacts with matter. Owing to differences in their intrinsic chemical composition and physical structure, different materials exhibit distinctive spectral response patterns. By analyzing spectral characteristics, we can automatically distinguish various features such as vegetation, water bodies, buildings, and farmland on satellite imagery. It also enables us to monitor crop health, assess water pollution levels, and evaluate forest pest and disease conditions. Furthermore, spectroscopy can be used for component detection, such as identifying specific types of surface minerals, providing critical support for geological exploration and resource surveys. However, directly analyzing vast and complex raw spectral curves remains inefficient. To translate spectral principles into quantifiable and operable practical tools, the field of remote sensing has introduced spectral index. Based on this, LiDAR360 provides a toolkit for calculating 113 types of spectral indices. Located under the toolbox in the Spectral Index Toolkit, it not only includes built-in tools for calculating common indices like NDVI and NDBI, but also offers a vegetation index, normalized index, geology and mineral index, and a spectral index calculator to meet the application needs of clients across various industries. Since the parameters for calculating spectral indices are generally consistent across different function dialogues, this video will use the Vegetation Index Calculator and the NDVI function as examples. Double-click the Vegetation Index Calculator function to activate its dialog. Load the spectral image data for index calculation. The data must contain wavelength information and supports formats such as .dat, .tiff, .img, and .hdr. The Band Select field will show the number of bands already selected and the total number of bands in the image data. Click the Spectral Subset button to manually select bands from the hyperspectral image. Based on the wavelength information of the bands selected in the spectral subset, the supported spectral indices will be automatically matched. Here, we will use EVI for calculation. Checking biophysical cross-checking enables a process that validates the correlation between the spectral index and the actual biophysical parameters of the features, ensuring the scientific validity and reliability of the index results. This is unchecked by default. Loading mask data will restrict the index calculation only to the valid areas of the mask. Loading ROI data will limit the calculation to the area within the minimum bounding rectangle of the ROI. Set the output path, click OK, and wait for the result to be generated. You can use the Pick Point tool to check the pixel value of the output results. Next, let's use the NDVI function to demonstrate how common spectral indices are calculated. For these functions, you only need to select the spectral image data for calculating the corresponding index. The software will automatically load the bands required for the calculation, such as the red and near IR bands for NDVI. You can also choose whether to use mask and ROI files. Once the setup is complete, click OK. Compared to the raw spectrum of features, a spectral index is specifically designed based on the spectral characteristics of particular features. For example, NDVI focuses solely on the contrast between vegetation's high reflectance in the near IR and high absorption in the red band. This ratio operation effectively minimizes interference from factors like soil background and illumination angle variations, significantly highlighting the characteristic of vegetation health. That concludes the introduction to the Spectral Index Toolkit. Thank you for watching.